Hi everyone, welcome to this lecture. So in this lecture, we will implement polynomial regression in Python. That is, we are going to solve our project 6. So I am here in my folder known as regression analysis, and this is my project 6. So click on this file so that we can open it in our Google Colab environment. So this is my project 6. For my project 6, I need NumPy, Pandas, and Matplotlib. Let's run this cell to import all these necessary files. Now, for this project, I am going to use a dataset known as polyreg.csv. So this dataset is present inside a folder known as regression analysis. We know that in order to read the dataset from the folder, we need to mount the drive and we need to set the path. So in order to save the time for this lecture, I have already mounted the drive. You can see here, the drive has already been mounted and I have already set the path. So the path is drive, my drive, course material. Inside course material, the folder is supervised machine learning, and inside supervised machine learning, I have a folder known as regression analysis. So we can confirm this path from here as well. We have a drive, then my drive. Inside my drive, I have a course material. Inside course material, there is a folder supervised machine learning, and inside supervised machine learning, I have a folder known as regression analysis. Inside this regression analysis, I have a dataset known as polyreg.csv. So now it's time to import the dataset. Let's import the dataset and let's see the dataset. So this dataset is an experience salary dataset. It has only 10 samples. That is, experience is the feature and salary is the target value. So I have only one feature in this dataset. Let's extract the feature and the target value. So let's run this cell because the feature is the experience and the target variable is the salary. So let's extract feature and the target variable. Now it's time to visualize both variables. So we can see that the plot between the experience, which is independent variable, and the salary, which is dependent variable, is like that. This is the scatter plot. So if I try to fit a straight line, it might not be a good idea to fit a straight line on this kind of a data set. We can see that it has some relation which may be fulfilled if I want to fit a curve on this data rather than a straight line. So we will see what is the best fit for this training data. So for this, I have to use polynomial regression, and I will use polynomial regression from Python library known as scikit-learn. So before this, I will reshape my feature. So this is the new shape of my feature. So I have transformed my feature into a column-wise representation. Now here I am going to apply polynomial regression. So the first I need to transform these features into the polynomial features. So for this, I will import polynomial features from scikit-learn.preprocessing. And first, I will use the degree of polynomial is equals to 1. So I will start from degree is equals to 1, and I will see the performance of the model. And then I will keep on increasing the degree until I will reach to the optimal model. So the first step is that I have imported the polynomial feature. Here I am instantiating the polynomial feature with degree is equals to 1. Here I am getting a function polynomial feature. I am fitting and transform this polynomial feature to my feature, that is to the value of x. Let's run this cell to get the polynomial feature, which is known as xpoly. Let's run this cell to see the feature. Now, if you see that, what happens is when the degree is 1, there is only one change. That is, the polynomial features append 1 at the first column of our feature. So this is our original feature. This is a matrix of our original feature. These are the value of the feature. So look at the change when degree is equals to 1. So when degree is equals to 1, there is no square term of the feature, no cube term of the feature, or no higher power term. There is only one which is appended at the first column of the x, and now it become xpoly. Now it's time to use xpoly and y, that is target variable, to perform complete polynomial regression. So I am importing linear regression from scikit-learn.model. Here I am instantiating linear regression, and here I am fitting my linear regression to my polynomial feature and target variable. Now, one thing we need to remember, that we use linear regression whenever we have to implement polynomial regression. But the difference is when we apply linear regression on the poly feature, it becomes polynomial regression. Therefore, before applying the linear regression, we have transformed our features into the poly features, and then we apply linear regression on the poly features. So when we apply linear regression on the poly features, it becomes polynomial regression. Now it's time to calculate the intercept and the weights, that is bias and the weight. So we can see that this is a negative value of the bias. We have two value of weights, that is 0, and the other value is around 40,000. So our weight is 0. So this 0 weight is for this column. It means this column is not establishing any linear relationship with the output variable, that is the target variable. Therefore, its weight is 0. Now, it's time to get the prediction from the model. So for prediction, we will write model.predict, and we'll get the prediction from our feature. Here we obtain the prediction, and here it's time to plot the polynomial regression model. So we can see that our model is a straight line. Why it is a straight line? Because the degree of our model is 1. We have passed the degree is equals to 1 in our first step. So this is a straight line. Let's see the performance. So we can see that the performance can be improved further, because r square is equal to or nearly equal to 0.8. So it can reach up to the value of 1. Other than this, we can see that there is a very high value of root mean square and mean absolute error. So we can see that this straight line is not performing well. So we need to increase the degree of a polynomial. So in the second step, I am increasing the degree from 1 to 2. Let's run this cell. Let's see the polynomial feature. We can see that there is another column which has been added when we set degree is equals to 2. So this column is the square feature. This column is the square of this column. We can see that the square of 2 is 4, the square of 3 is 9, and similarly the square of 10 is 100. So these are our new polynomial features when we set degree is equals to 2. Now import linear regression, or repeat all these steps. Import linear regression from scikit-learn, fit the linear regression, see the value of intercept and coefficients. Now we can see that again, this is a 0 and this is a negative value of the weight. So we get the negative value of the weight for this column and the positive value. So the negative value doesn't mean anything. It means that this has a negative correlation with the output variable. So it is establishing a negative relationship, negative linear relationship with the output variable. That's why the value of its weight is negative. So the value of the square coefficient is positive, which is 6890. So this weight is positive, this weight is negative. Negative weight means that we have a negative linear relationship between this feature and the target variable. Here is the time to get the prediction, and now it's time to visualize our polynomial regression model of degree 2. We can see that its performance is better than the polynomial model of degree 1. It's trying to learn all the pattern of the dataset. Let's see the performance by evaluating the matrices of the regression. So we can see that we have improved a lot. Our R2 value is now equals to 0.98, and RMSE and mean absolute error has also reduced. But there is still a margin of improvement, especially in root mean square error and in mean absolute error. Let's increase the degree further from 2 to 3 and repeat all the steps. So now I am putting degree is equals to 3. I am creating the polynomial feature, and now I can see that I have one more column here. One more column means that this is the cube of the feature. So this is x. Now this is x square, and this is x cube, and x cube because degree is equals to 3. Now repeat all the steps now and see the shape of our polynomial regression model. And now we can see that it is better than the degree 2. It is trying very much to learn all the hidden patterns of the dataset. Let's observe its performance. So remember, the RMSE is 17,000 and MAE is 15,000 when degree was 2. Let's see these values when degree is 3. Now we can see that these values has reduced a lot. Now RMSE is only around 7,000 and MA is 5,500 approximately. And R2 has also reached near to 1. So we can see that by increasing the degree slowly and slowly, we are reaching to the optimal model. Now it's time to get the degree is equals to 4. When I put degree is equals to 4, here are my poly features. So I can see that I have one more column. So this is my 1, this is x square, this is x cube, and this is x raised to power 4. Now repeat all the step. Here I am importing linear regression and fitting this to my data set, that is x poly and y. Here I am printing the intercept and I am also printing the weights associated with the features. Here I am getting the prediction. Here I am observing my polynomial regression model, and we can see that it is slightly better than the polynomial of degree 3. But we need to confirm this from the metrics of the regression, that is root mean square error, mean absolute error, and R square value. So what is happening over here? The root mean square value was 6,700 and MAE was 5,500 when degree was 3. Let's check it for degree is equals to 4. So we can see that we have nearly reached to the value of 1. And now we do not need to go further, because if we increase the degree, our model will start going into an overfitting situation. That is, it will try too hard to fit the model. So there is no need to make our model more complex, because we have already reached to 0.999 value, which is approximately, or which is very, very near to 1. So in this lecture, or in this project, we learn how to implement polynomial regression in Python. We see that in order to implement polynomial regression, we need to start from degree is equals to 1, and then we slowly increase the value of the degree, and similarly we increase the value of our polynomial feature. Then we fit linear regression on our polynomial feature to make it a polynomial regression. So in this way, we slowly increase the degree, and finally we reach up to the optimal point where our model performance is close to the ideal situation. So I hope you understood this lecture or this project. Thanks for listening, and I will see you in the next lecture.